let's learn about the new topic, that is conversion of decimal into the rational number, that is p by q form. First of all, we are going to discuss about the terminating decimals. Then we are going to discuss about the non-terminating repeating decimals. So first of all, let's start with the terminating decimals. So let's start with the most basic one that you know very well as well. So let's write 1.5. How to convert this into form of the p by q? That is, if you remove the decimal, that is 15 by 10. Now let's do the cancellation if possible. In this case it is possible, so 5 2s are and 5 3s are. So what is the p by q form of this? That is 3 by 2. Let's take one more example, 0.012, right? So let's write only number without 0, that is 12 over here. And how many places are there? 3. So 3 zeros over here and 1. Very simple way to do it, right? I think we can divide by 4. So here by 3, and so let's write 3 over here, and in this case 4, I think 425s are 250 will be there. So around 250 here. So 250 it is. Very simple, right? Let's take one more example of the normal number. Let's say 6.5, right? So here we can write 6165 over 10. So let's do the cancellation. Here 2s are and here 5 we are dividing with, that is 3s are, and 1 5, that is 33. So 33 by 2 is the p by q form. So when we deal with the terminating decimals, that's very easy to do it, right? You just put the 10 or maybe 100 or 1000 based on the number of digits after the point, and you do the proper cancellation if possible, otherwise you keep it as it is. So this is how we convert the terminating decimals into p by q form. Now let's learn about the non-terminating repeating decimals. Now let's discuss the conversion of decimal non-terminating repeating decimal into p by q form. Let's start with the first example. So let's take an example of 0.7 bar. We want to get the p by q form of this non-terminating repeating decimal, right? So first of all, let's start that let x is equal to 0.7777 dash dash dash, right? 7 bars, so means you can write up to your wish. Now what I'm going to do, I'm going to multiply by 10. Why I am going to multiply by 10? Because after decimal there is only one number which is repeating. So I'm going to multiply by 10 on both of these sides. So 10 into 0.7777 dash dash dash, right? So here that is 10x is equal to 7.777 and add one more 7. So you can keep writing 7 as many times as you wanted, but make sure that you maintain the consistency. For this one, there are 4 times we are writing 7, and here also 4 times as well, right? There is a reason behind that. Now let's give this to relation as number 1 and this relation as the number 2, right? Very important, right? First what we did, we have the x is equal to something, right? You take any variable. I've taken x, y can also work out, right? Then you multiply 10. Why 10? Because we have only one decimal, one digit which is repeating after decimal. So that's what we did. Now we are going to subtract. Let's write subtract 2 and 1. So how are we going to do? Let's write 10x is equal to 7.7777 dash dash dash, and another is x over here, that is 0.7777 dash dash dash, right? And we are talking about subtraction. So 10 minus here nothing means 1. So 9x is equal to, see, 0.7. If you are not writing correct number of 7s like 3 over here and 4 over there, you are going to get some number, and that's incorrect way to do it. Remember, right? So I can write that x is equal to what? 7 by 9 is equal to 0.7 bar, right? So it can be written in the form of 7 by 9. Very easy it is. right? This is the most basic sum of the sums that we are going to discuss, right? Let's assume x is equal to 0.777777, right? Multiply by 10 because there is only one digit. Suppose if I have two digits, then I will be multiplying by what? 100. We are going to discuss the next question based on that. Afterwards, give this relation 1, relation 2 and subtract these two relations. So this is what you get it. Make sure that you should get after 7 or after whatever number all zeros. Then only you can say it is correct. Now let's discuss the second one, that is, let's take 0.23 bar. Previously we were having only one repeating number after decimal. Here we have two. So again let's start. Let y is equal to 0.23 then 23 dash dash dash, right? Now see, there are two digits after the point, so we are going to multiply by what? 100. So let's multiply 100 into y is equal to 100 into 0.2323 dash dash dash, right? So here it is 100y and here it is 23.23, right? So we can add more, that is 23 and dash dash dash. So let's give the number to the relation. Let's say this is the relation 1 and this is the relation 2. And we are going to do what? Subtract both of them, right? So let's start with the subtraction of both of them. So subtract, right? So here we can write first of all 100y is equal to 23.2323 dash dash dash, and here y is equal to 0.2323 dash dash dash. Let's subtract them. So 100 minus 1, that's what? 99y is equal to, here let's start from here, 0 0 0 0, right? And here 2 3. So y is equal to 23 by 99. Very simple it is, right? So previously we had only one decimal, right? One digit. Here we have two digits, so we multiplied by 100, right? Now are you able to identify some pattern over here? If it is 0.7, the answer is what? 7 by 9. See, 7 by 9 over here. And if it is two digit 23, that is 23 by 99, two times, right? So if we write just like, let's say 0.437 bar over it, and if I want to convert it in this form, so what could be the answer? That is 437. And as there are three digits, there will be 3 times 9, right? You can do the calculation and check it out. So this was the third sum, just we did like this only. You can cross check it that we are getting this answer or not, right? So this is the first and very simple basic case of converting the non-terminating repeating decimal in the form of p by q, right? So you take x is equal to something, variable, anything you can take it, right? If there is only one digit, multiply by 10, two digit multiply by 100, three digit multiply by 1000. Then give the relation number 1 and 2 and subtract bigger minus small. Always do that one. You'll get the positive answer, right? And make sure that here you get all the zeros, right? If you get 0, then only it is correct. Otherwise it will be incorrect. So this is how we convert the decimal into the rational number form. Remember this pattern, right? So let's discuss the next sum. Let's discuss one more case for the non-terminating repeating decimals conversion to the fractions, that is p by q form. Let's take example 18.48 n bar. So far the questions we discussed was all about 0 point something. Now we have number over here, so what to do in that case? First of all, let's start with the basic step, that let x is equal to 18.4848 dash dash dash, right? Okay, so what was the second step? We were counting that how many digits are there after the decimal that is being repeated. So there are 2. So we are going to multiply with 100, right? 2 zeros should be there. So let's multiply and let's give this number, this relation number 1. You know the reason behind that. So let's multiply 100 into x is equal to 100 into 18.4848 dash dash dash. That being done, now let's write here, that is 100x is equal to 18. These two places will go that side, that is 1848.48 and extra 48. Remember that, right? We need to maintain the consistency. And let's give this relation as the number 2. Now what are we going to do? We are going to subtract. So let's do the subtraction here. That is 100x as it is equal to 1848.4848 dash dash dash, and minus here the first one, that is x, is equal to, we have 18.4848 dash dash dash. Done? So let's subtract 8484. All of them are 0. Simple. Then 8 minus 8 is 0 here as well. 4 minus 1, that is 3. Here 8. Here 1 is equal to what? 99x. So we can write x is equal to 1830 divided by what? 99. If you can do any kind of cancellation, then you can go ahead with that as well. I think 11 will not work. Let's try with 3. So 8 and 1, that is 8 and 1, that is 9. 9 and 3, that is 12, right? So I think we can divide with the 3 over here. So let's start. So here 6 are, right? 3 6 are, then 1s are, and 0 over here. And here if we divide, that is 33. So that is 610 over 33. So fraction form of this 18.48 bar, right? That is what? 610 by 33. Very simple method it is, right? It doesn't matter you have here 0 or some other number. You are going to follow the same method, right? So let's repeat. First of all, x is equal to whatever fraction, whatever decimal is given over here, multiply by 100. The reason behind that, it is still same, that you have two decimal places, so multiply by 100 on both of the sides. Done. Afterwards, subtract both of these results and get the answer. And if you can simplify at the end, then simplify further. Let's take one more number. So we can take here 0.2562. Let's write here 0.2562 bar. Okay. Now this is something different. So far we were having all the numbers after the point under the bar, right? But here these two numbers are not under the bar. So let's start how to approach this kind of questions. Let's say let y is equal to 0.2562 bar, right? And our first target is to achieve this kind of decimal expansion. This kind of means what? That bar, whatever numbers under bar should be after the point only, right? And without bar should be before the point, right? So we want to shift this 25 over that side and see how many numbers are there. 2. So we are going to multiply with what? 100. So let's multiply 100 into y is equal to 100 into 0.25 and 62 bar here. So we can write that is 100y is equal to 25.62 bar. And let's write 62 here as well. Now see, our sum is starting from this point only, right? This is the extra step we need to do. This is the extra. If there are 3 numbers which is not under the bar, then we will be multiplying with 1000. One number multiply with 10. It doesn't matter, right? So this is what we are going to start our sum from, right? Now let's shift this 22 also that side. So see, there are 2, right? Under the bar there are 2 numbers. So again we will multiply with 10. 100, remember. So 100 multiply with 100y is equal to 100 multiply with 25.6262 dash dash and dash. So here that is we are going to have 10,000 because 4 zeros, and here 25.6262 dash dash and dash. Now here if you observe, there are so many results we are having. Here we had only 2, right? You have y, you multiply by 100, you multiply by one more 100. So which 2 are we supposed to subtract? That's very important point over here. If you subtract two results which are not you are supposed to subtract, you are going to get the incorrect answer. You won't be able to get the proper answer. So which 2 you need to subtract? Remember, our sum started from this point, right? This is the first result we are going to give as the name. This is the 1 and this is the second result, right? Here 2, right? This is just for this calculation is to get this result, remember. So we are not supposed to subtract with this result, remember that, right? So we are going to subtract this 1 and 2. So let's write over here. Yes, we can use green pen. So let's write 10,000 here. So y is equal to 2562.6262 dash dash dash, and this is the another result that we are supposed to subtract with. So 100y is equal to what is over here, that is 25. So 25.6262 dash dash dash, right? And we are dealing with the subtraction. See, 0 0 0 0, very nice, right? 0, then 0 0 and 0. 2 minus 5 is not possible, so 12 and 5 over here, so 7, and we have 3 5 as it is, 2 as it is. Here y is okay, let's write y, sorry, then 0 and 0, here 9 and 9, right? So value of y in this case is what? 2537 over 9900. If you can divide, you can divide it. If it is not possible, keep it as it is. Remember, this kind of answer will be little bit larger. So far we were getting only 2 digit and 3 digit, but we have 4 digit in numerator and denominator as well, right? So this is a special case of extension of this one. You can say that you take y is equal to something, whatever question is given, then first of all shift this 2 digit that side. That being done, now we need to shift 2 more digits which is under the bar. That being done, most important step, which 2 result to subtract over here. Don't subtract with the y, that is incorrect answer. You will not be getting 0.0000 over here, right? And I think you should place dash 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 here as well, and I think yes, here as well, that can work out, right? So after subtraction, right, you simplify and get the answer. So we are going to discuss 2 more problems related to this topic. Let's move on to that. Let's do one interesting question related to converting to the fraction form. Let's start. Let's take an example of 0.9999 dash dash dash. You want to find the p by q form of this one. So let's start with the normal method. Let x is equal to 0.9999. So 9 is the repeating digit over here, right? And that is only 1. So let's multiply by 10. So 10 multiplied by x is equal to 10 multiplied by 0.9999 dash dash and dash. Here it is 10x is equal to 9.9999 dash dash dash. So we have 2 results over here, right? The first one is this one, right? And the second one is this one, right? So we have these 2 results. Now what are we going to do? We are going to subtract. That's what we are doing so far. So let's start with that. Here 10x is equal to 9.9999 dash dash dash, and here x is equal to 0.9999 dash dash dash, and subtract. So here 0 0 0 0, we can write dash dash, and here point, and 9 minus 0 is 9, is equal to 9x. So x is equal to what? 9 by 9, that is 1, right? So we take approximation generally that 0.9999 is equal to 1, and we proved that 0.99999 is equal to what? 1. So this question can be asked in the reverse manner as well, that prove that 0.999 is equal to 1, right? So we just need to convert into fraction form. No need to just guess it, right? This is the proof of it, right? So this is how we convert the non-terminating repeating decimals in the form of p by q form.